They were feared warriors who terrorized much of northern Europe and beyond through the Iron Age. But carried by their longboats, the Vikings also circumnavigated across vast stretches of open ocean, traveling as far as the Middle East and even North America. Now researchers have shed new light on how they may have achieved this feat, with the help of the sunrise and sunset. Scientists have studied the techniques the Viking sailors may have used to help them pick their way from Scandinavia to far-flung places. Historians have long suspected the Vikings used sun compasses to orientate themselves while at sea. In cloudy or foggy weather, they also may have used crystals known as sunstones to help pick out the sun. Now, in a series of studies published by the Royal Society, a team of physicists at Eötvös University in Budapest, Hungary, have tested whether this is possible. They found that the Viking navigators would have needed to follow 3 steps to ensure they could keep their vessels pointed in the right direction. First, they would have determined the direction the light from the sky was being polarized using 2 sunstones. They could then use this to determine the direction of the sunlight and calculate its elevation. They could then use a shadow stick to cast the appropriate shadow on the sun compass to work out where north was. In 2 studies published earlier this year, the researchers showed that the first 2 steps were possible depending on the type of crystal used for the sunstone. They found that in overcast conditions calcite gave the most accurate reading while cordierite and tourmaline were more error-prone. But in a new experiment, published in the Proceedings of the Royal Society A, the research team have shown that while the Vikings could have estimated the position and elevation of the sun with sunstone, they would have been best to do it when the sun was lowest in the sky. This means that if the Vikings took readings shortly after sunrise and before sunset, they are most likely to have stayed on the correct course. Dr. Gabor Horvath, an expert in environmental optics at Eötvös University who led the research, said, "The theory of sky polarimetric Viking navigation with sunstones is widely accepted. According to our findings, the ideal periods for sky polarimetric Viking navigation are immediately after sunrise and before sunset, because the north errors are the lowest at low solar elevations." There are few clues as to how the Vikings navigated across the oceans in the archaeological record. A fragment of a wooden dial, dating to the 9th century, found in the ruins of a convent in Greenland is thought to be part of a sun compass. With such a device the Vikings would have been able to find the direction of north, and so work out their own heading, with high precision, but only in clear weather. Some experts have suggested that the Vikings used special crystals called sunstones that polarize the light to help them find the sun when it was covered by clouds or fog. Sunstones are described in some of the Viking sagas, but there is little physical evidence of what these were. Several potential crystals such as calcite, tourmaline and cordierite can be found on the beaches of Norway and Iceland where the Vikings are known to have lived. However, the theory that the Vikings used sunstones has been controversial. In a study published in January this year, Dr. Horvath and his team showed that it was possible to use these stones to work out the direction of light was coming from. This is because the light passing through the crystals was polarized, meaning as it was rotated it would allow different amounts of light through depending on its orientation. When the amount of light passing through was at its brightest, it means it is aligned with the polarization of light in the atmosphere. Markings on the crystal surface, made by calibrating the stone in clear conditions, could reveal where the direction of the light was coming from. Dr. Horvath and his team found using 2 sunstones and drawing 2 large circles parallel to these engravings it was possible to work out the position of the invisible sun. In their latest paper the researchers examined whether it was then possible to estimate the elevation of the sun and so project an imaginary sun ray onto the surface of the sun compass by adjusting the shadow stick to the appropriate height. They claimed this estimation of solar elevation was probably performed using measures of fists and fingers. Using 10 male partific planets, the researchers asked them to estimate the position of the sun in a digital planetarium using black dots to represent the spot determined using the sunstones. They found that in 2,400 tests, 48% of them were more accurate than 1 degree. They found that the most accurate estimations was when the sun was close to the horizon. This, they claim, suggests the Vikings probably navigated immediately after sunrise and before sunset to ensure their headings were as accurate as possible. Writing in the paper, the researchers said, in reality a Viking navigator had to perform such an estimation with regard to an actually unseen sun. The latter is obviously a more difficult task. Thus, the elevation errors presented in this work underestimate the real errors of the third step of skypolarimetric Viking navigation. On the other hand, Viking navigators were surely more experienced in the estimation of elevation angles than our test persons.